All right, let's pick up on section 2.1 on using quadratics, where we left off. So we left off on that problem right there. Um, and let's go through and think about how we can take what we know about quadratics and solve some story problems. So sometimes these can give you a little bit of trouble. I mean, my gosh, this is just one little sentence. Shouldn't be that difficult, but for some reason it tends to be. So let's think about this and see how we could solve this. So here's what it wants. It uses a familiar term here. So it's got maximum in it. It says find the maximum product of two positive real numbers whose sum is 60. So let's do this. Let's stop right there and let's read this again. It says we want to find the maximum product. Remember, product means we're going to be multiplying two things together. Okay? Two positive real numbers. Two positive real numbers. Okay, so we want to have a maximum product, and we've got two numbers, and we don't know what those are. So usually, if we don't know what numbers are, we'll use variables to represent them. So let's say the first one is x and the second one is y. And we want to find the maximum product. Well, the product of the two of those, I'll use P for product, is x times y. Now, here's the problem. If we're trying to find the maximum of this right here, I mean, it's hard enough working with one or two variables, let alone three variables. So what we need to do is we need to find some way to eliminate one of the variables. And then here's the key to figuring that part out. It says two positive real numbers whose sum is 60. So we know something about these two numbers right here. We know that their sum, in other words, when we add those together, x plus y, we end up with 60. So the thing we don't like about this is there are way too many variables to deal with. This doesn't even look familiar. It's not like the quadratics that we've seen up above. But what we can do with this is we can solve this equation for y. So y is 60 minus x. And that means wherever there's a y, we can put a 60 minus x. So wherever this y is right here, I'm going to put 60 minus x. So here's what we've got now. We've got the product would be equal to x times 60 minus x. And if you think about how this would work, we could even figure this out numerically, or at least come up with this idea numerically. Let's say that the first number was 10 and they add up to be 60. The other one would have to be 50. Well, if this one's 10, 60 minus 10 would be 50. There's our 10 and there's our 50. If the first one was 30, the second one would have to be 60 minus 30. It would have to be 30 also. So there are a couple numeric numbers, or numbers where we can see that if you know what x is, you can figure out what y is. Well, the key to solving this is this right here. Once I have this, I'm all set to go. Now, there are a couple different things that I could do with this. I could take the time to go through and multiply these together and think about that as a function of x. So this would be 60x minus x squared. We'd normally write it negative x squared plus 60x. And then I could think about, well, let's see, this is a parabola that opens down, okay, because it starts with a negative in front of the x squared. A would be negative 1, in other words. Okay, and then I could figure out where so if it opens down, I'm going to have a maximum, which is good because that's what we're after. And then I could use the negative b over 2a formula to figure out the x coordinate of the vertex. And that would be just fine. That would work okay. Or I could look at this and I could think about it this way. We've talked quite a bit about zeros of functions, x-intercepts. Well, think about this. The thing that would make this one 0 is 0. And the thing that would make this one equal to 0, when is 60 minus x equal to 0? Well, that's when x is 60. So these are also the x-intercepts. So if I've got a parabola that I know opens down and it crosses at 0 and crosses at 60, well, the only way this could possibly be a parabola that opens down is if it looks something like that. And remember, we've got this center line, this axis of symmetry. If this is 0 and this is 60, what's this x coordinate right here got to be? It's got to be smack dab in the middle. It's got to be 30. So remember, this is going to be x. This is going to be the product of x and that other number, 60 minus x. So the x coordinate of the vertex has got to be at 30. So that means x is 30. If x is 30, then we could figure out what the area is by plugging that into this function right here. or sorry, not the area, but the product. So if the first one is 30, the other one's 30, so we'd multiply those together, we get 900. So that's the product of the two of those. It says find the maximum product. So the answer on this problem is 900. The two numbers that would produce that, the first one would have to be 30. That's the first one. And the second one would have to be 30 also. Okay. Now I could solve it this way. Watch what happens if I do negative b. So that's going to be negative 60 over 2 times a. That's negative 1. So that's a negative over a negative. That's going to be a positive. 60 divided by 2 is 30. So that means x is 30. Then I can plug this into the original equation. So that would be negative 30 squared plus 60 times 30. So this is going to be negative 900 plus 1800. That's 900. Okay, same answer we got over here. And of course, the two numbers, if x is 30, then y would be 60 minus 30. So the two numbers are 30. Okay, so same answer either way. Okay, but this is kind of a nice graphical way of doing it. And we don't have to use those formulas or anything. Works out very nicely. So the next one says, find the maximum product of two positive real numbers. Okay, very similar to the one before. Only this one says the sum of the first and 3 times the second is 36. Well, let's set this up the same way. Let's say the first one's x, the second one is y. Their product would be x times y. And again, what we don't like about this is we've got two variables. Let's get rid of one of those. And then we're going to focus in on this statement right here. It says the sum of the first and 3 times the second is 36. So if I take the first one and then add, that's the sum, 3 times the second one is y, so that would be 3 times y, that's got to equal 36. Well, this one's kind of interesting. On this problem up here, it didn't really matter which one we solved for. We solved for y because we tend to like working with x's. If I tried to solve for y here, I'd get this. I'd get 3y equals negative x plus 36, and then I'd divide everything by 3, so I'd have fractions to work with. So that may not be a good idea. Let's do this. Let's solve this for x. So x would equal 36 minus 3y. So wherever there's an x, I can put a 36 minus 3y. So now let's change this. This is going to be the product of x, which is 36 minus 3y, times y. And again, if I were to take the time to multiply through and think of this as a function, this would be minus 3y squared. This would be plus 36y. Now, I've got a function of y this time. Not a big deal. I could use the negative b, so negative 36 over 2a. So that's going to be negative 3. So that's going to be negative 36 over negative 6. So that's going to be 6. So that's what y is to produce the maximum. Or I can think of this. I'm going to call that y because that's the independent variable here. That's the product. The 0 that comes from this one would be 0. The 0 that comes from this one, let's think about that. When is 36 minus 3y equal to 0? Move that over. 36 equals 3y. That would be y equals 12. So this y-intercept is 12. Or sorry, this y-intercept, I suppose we'd call it. Okay, and this is a parabola that opens, look at this right here. Okay, it opens down. We know for a fact it's got to open down. So our parabola would look like this. And if this is 0 and this is 12, what would that center point be right there? It would have to be 6. So if I know y is equal to 6, so I've got that answer, I've confirmed that 2 different ways, I can then take this and plug it in right here, and I get x is equal to 36 minus 3 times 6. So that's going to be 36 minus 18, so that's 18. So x is 18. Okay, and it says find the maximum product. Well, what I found is the two numbers. I then just multiply the two of those together to get the maximum product. So the maximum product in this case, if I multiply these together, I believe that's going to be 108. That would be the maximum product. So these are the two numbers that make the maximum product under these conditions right here. That is the maximum product. So again, just to make sure we're clear, the answer on this one, because it asks for the maximum, 900 here, 108 on that one right there. Okay? If you need to watch those again or do something else to catch that, go ahead and pause the video or rewind it. Let's take a look at example number 8. So given the problems that we've solved, we've solved some similar to this in class before, we've got a rectangle that has a perimeter of 200 feet. So if we add up the outside of the rectangle, it's 200 feet. What we'd probably want to do is we'd want to probably make a rectangle that has the maximum area given that condition right there. So let's draw a picture. We've got a rectangle. And if I add up all of the outside, I end up with 200 feet. Well, if I don't know what this one is, let's use a variable to represent that. This one would be the same thing. That one's going to be x as well. This would be y, and that would be y. So the perimeter here, well, let's talk about the area. If I were going to find the area, it's going to be x times y, base times height, length times width, however you remember that. So now I've got the same issue I ran into before. I've got to get rid of one of these variables, and here's what we do. If I took these and added them all up, I'd have an x plus a y plus a y, and that should equal 200. So that would be 2 x's plus 2 y's equals 200. So I'm gonna get rid of the y's, so I'm gonna solve for y. So that would be 2y equals 200 minus 2x. So y is equal to, if I divide everything by 2, 100 minus x. And then I can put this in place of that. And then what I've got is the area as a function of x. So this is going to be x times 100 minus x. And then again, take a look at this. If you need to, it doesn't matter which method you use here. This is negative x squared plus 100x. If I write that in descending order, opens down. So we're definitely going to have a maximum. If we think about what this would have to look like, this is the area axis, and this is the x-axis. Let's look at it from the perspective of the x-intercepts, or the zeros. This would be 0. The x-intercept that comes from 100 minus x would be 100. So I've got 0 and 100. Where would that center line be? Where would that axis of symmetry be? Smack dab in the middle at 50. So that tells us that x is 50. Let's figure out what y is. If I know x is 50, I can come over here and I can plug it in right there. So I'd have 100 minus 50. So y is also going to be 50. And then if we said, what is the maximum area? Well, the maximum area would just be the two of those multiplied together, which is the same thing you'd get if you plugged in a 50 here. So if I figured out what a of 50 is, that's going to be 50. 100 minus 50. 50 times 50, answer there is 2,500. So 2,500, and because the units here were in feet, this is going to be in square feet. So here are the dimensions. If we were going to make this rectangle, we'd have to make sure that it's 50 feet by 50 feet, and then we'd also know that the area that it would enclose would be 2,500 square feet. Okay. Last type of problem here that we're going to take a look at. Nice application of parabolas, quadratics, that sort of thing, is we're going to pretend like we owned a business. Okay, and when you own a business, there are a couple things that are important. One of them is the revenue. So think for just a second, if you need to stop and do a web search, think about what revenue is, or find out what revenue is. I'll give you a second to do that. I think what you'll find is revenue is income. Just income, and we're going to think of it as income generated when we sell something. Okay, so it's the money that we bring in when we sell something. That's how we'll think of it here in our business. Okay, how does revenue differ from profit? So if you need to take a look at that. Revenue is definitely different than profit. Just because you have a huge revenue doesn't mean you have a huge profit. Because we've got a lot of money coming in doesn't mean that we've made a lot of money. Okay. Well, profit is revenue minus expenses, okay? Or income minus expenses, okay? That would be our revenue, okay? So let's say we owned a business and we figured out a mathematical model that told us what the revenue is. So R of X equals 1000X minus 0.2X squared. And we run a bike shop, we sell bikes, and this gives us the revenue. Well, what would we be interested in? Well, if we were running the business, we'd probably want to generate as much income as possible. We'd want to have as much money coming into the business as we possibly could. So we'd be interested in what is the maximum revenue? And maybe if X represents the number of bikes we sell, we'd want to know how many bikes we have to sell in order to maximize this revenue. So take a look at this right here. It's written in the wrong order, but this tells us something. This tells us that this is a parabola, and it opens down. Now, in every one of these cases, we've had a parabola that opens down, so we're going to end up with a maximum. It is possible that we might be interested in a minimum, maybe when we want to minimize our expenses or something like that. But all the ones that we've dealt with today are very similar like that. So it's a parabola that opens down, and what we want to figure out is how many do we have to sell in order to maximize the revenue? Well, all we need is the x coordinate of the vertex. So on this one, let's go ahead, rather than factor through this, let's do the negative b over 2a stuff, and then we'll figure out what we get when we plug that in. Okay, so remember, the formula looks really ugly, but the negative b over 2a part is pretty straightforward, and then all we do is just plug it in. So negative b, careful here, it's not this one right here. If you need to rewrite it, let's go ahead and rewrite it. Negative 0.2x squared plus 1000x. This is b and this is a. So negative b would be negative 1000 over 2 times a is negative 0.2. So this is negative 1000 over negative 0.4. And let's go ahead and check that on the calculator. So I'm going to have a positive, and so I want to figure out what 1000 divided by 0.4 is. Get 2500 oddly enough. Let's just double check that. Negative 1000 divided by, let's put parentheses, 2 times negative 0.2, close the parentheses, same answer, okay? So that would be 2500. So that's 2500, comma, and then let's figure this out. That's x. Let's figure out what r of x is. So we're going to plug 2500 into this one right here. So let's just come back here. And again, one nice thing about this is let's go ahead and type in 1000. And instead of typing in 2500, I'm just going to grab the last answer. Okay, second answer. If you want to type in 2500, you're welcome to. Minus 0.2, and then times that last answer squared. So we get 1,250,000. 1,250,000. Now let's interpret this. Let's make sure that we understand what this is. X is the number of bikes we sell. So this is bikes sold. Gosh, I wonder what type of bikes these are. So this is bikes sold, and this is revenue. Okay. So these are dollars. Okay. This is our revenue. Let's call that revenue and put dollars right there. So if we sell 2,500 bikes, our revenue is going to be 1,250,000. So again, if you need to watch this again, if you need to look at some other examples or something like that, please do so, or come and ask me a question. Thank you very much.